Yeah, so today's session will be on three important yet very interesting topics that are called SSTI, RCE, and OS command injection. And this will be a very short session. It'll just be 1 hour long. And we'll also have a few basic demos from each of these topics so that you guys get an idea of what each topic is basically all about. And the first topic that we'll be looking at is called SSTI or server-side template injection. SSTI is basically a vulnerability in which an attacker manipulates template syntax to inject and execute malicious code. Now, what does this mean? First of all, what exactly is a template? Template is any kind of a kind of placeholder that is used by the application in order to, render and display data that is dynamic. So any kind of data that changes, on the go as the application is being used and hosted by different users is considered as dynamic data. For instance, this could be user names that are relevant to each user, or any kind of data that changes as the application is being used is considered as dynamic data. And in order to render data that is dynamic, right, applications typically use what are called templates. So it will be basically a bit of application code in which there is a field which changes for different users, and applications use templates to display data that is dynamic like this. And SSTI typically involves injecting, your own bit of application. An application would typically be written in a language that is relevant, right? In case of Python, we have Flask, which is used to host applications, and Flask has a template engine called Jinja, which is used to render dynamic data on the website. And in order to exploit SSTI on a Flask app, an attacker would inject their own bit of malicious, template, a Python code into the template in order to execute it. And that's how SSTI typically takes its form. And yeah, template engine, like I said, template engines are tools used by web applications to generate dynamic HTML content. And uh, they take in they take in dynamic content like usernames and items selected by a user in case it is some kind of a shopping application, and then they place it into a placeholder, and then they basically renders it on the web page. And these are some commonly, just a second. These are commonly used template engines. For example, Python uses Jinja too, and PHP uses Twig, and FreeMarker and EJS are also examples of template engines. Now, how do SSTI vulnerabilities arise? SSTI is caused when user input is directly concatenated into a template rather than being passed in as data. So there are multiple use cases of template engines, right? In case a template simply takes in a variable and places it into a placeholder like this, and then renders it, then that would typically not be a vulnerability. That is, if users are not directly able to manipulate this data, as in this variable, right? Then they would not be able to exploit an SSTI vulnerability in this case. So in this case, the variable that's already present is simply being passed on to the template as data, right? And then it's just simply being rendered. In this case, it is not vulnerable. But then let's look at the case in which a template injection vulnerability is possible, right? So here it's rendering this string, and what's the string? It has this string appended to this bit of PHP right here. It's just essentially taking in the parameter called name from the get request, right? And then it is appending it into this string. So dear and then space and then followed by whatever is sent in as part of this parameter into the website as part of the get request. So if a string like this gets rendered on the web page through this template engine, right, then that would be a problem. So here an attacker can, yeah, is
Yeah, I just had a small doubt. I didn't understand like what you meant by template engines. Could you like elaborate on that a bit?
Yeah, so basically template engines are simply, tools that process templates and, control entering data into it and take care of rendering it on the web page. That's basically it regarding template engines. That's all they do. Like they basically control, you know, this rendering of whatever string that is present as an argument, you know, as part of the template.
Oh, so do you mean like since you said that we are working on dynamic work pages, so basically like whatever the user enters, like
Yeah.
managing that stuff is what template does.
Yeah, and rendering it is also taking care of them. And if the web page does not involve displaying any kind of data that like this, then you wouldn't really require a template engine. But then as long as you need to display any kind of data like this, right, then yeah, typically a template engine would be involved.
Okay, yeah, thank you, understood.
Yeah, okay. And yeah, so here if an attacker is able to manipulate this parameter, right, and then inject their own bit of, you know, in this case, it's PHP. So if they are able to inject their own bit of, arbitrary PHP code into this and get it to execute, then that would be a problem. So here what happens is dear and then whatever comes after this gets rendered on the web page as right. And then as soon as that happens, this bit of PHP code gets executed. And then the ramifications of SSTI are very, very complicated. Like you can have anything from simply defacing the web page to even gaining full, control over the web or server that is hosting the web application. So, yeah, that depends on how, secure of an environment that is, right? So if there are no security methods in place, then an attacker can even gain full control over the server. So, the impacts of SSTI are very, very, severe. And yes, so this is what I basically mentioned. As long as an attacker is able to manipulate any parameter, and then if this parameter gets placed onto a template, then yeah, that would lead to SSTI. Now, yeah, the impacts of SSTI. They can expose websites to a variety of attacks depending on the template engine and how exactly it's being used. And yeah, the probably the most severe effect of a successful SSTI attack would be achieving remote code execution and being and obtaining full control over the server, depending on how secure it is and how how privileged the user that is executing these commands are. So we'll get to that in a bit. And yeah, typically you would detect the presence of an SSTI vulnerability by entering in certain characters that may lead to a template injection exploit, and that really depends on what engine is being used. So different template engines have different syntaxes for managing templates, and most of them involve using curly braces. Some may involve using these special characters. So any of these, there are tools that take care of this. They basically try every possible combination of these characters and figure out which template engine it is, and then try injecting their own payloads. So, and yeah, if you manually try injecting any of these characters, and if an exception is raised, right, then that could mean that and there's a template engine that is involved, and the payload the string which contains these characters that you've entered has invoked an error, and that basically gives you an idea of what template injection is an engine is being used, and that is a very important clue in leading to a successful exploit. So, and yeah, that is also a proof of concept for an SSTI vulnerability. And so depending on the context, you would, approach it in a different ways. So in most cases, you would have plain text context, in which the typical, example would be render, and then there would be a string onto which your parameter gets appended. So if you enter something like this, right, then what happens is the template engine renders this string. So hello, and then this gets appended to it, and then that basically is passed as code that is in the language as in the same language as that of the application. So if it's a Flask application, right, they would essentially plug this into the template and then render it, and then it would simply evaluate 7.7 7 multiplied by 7. And if you get hello and then 49, then that is a good indication of the presence of a template injection vulnerability. So this is generally the very first, POC payload that pen testers would use in case of applications that are possibly vulnerable to template injection, right? And then yeah, so of course, the very first step in every SSTI attack is to identify. Yeah, so once the vulnerability has been discovered, that is, once it is proved that there exists a template injection vulnerability, the very next step would be to identify the template engine being used. It's engine instead of injection. I'm sorry about that. And yeah, this is important because different template engines mean that the app language being interpreted is different. So different template engines have different syntaxes for managing templates. And if it's a Flask app, you would require a Python payload. And if it's a PHP app, you would require, I mean, if it's an app that uses PHP in the backend, you would require PHP code. So, and there are multiple ways to figure this out. You can either submit invalid syntax of different languages to try and figure out which, error, which language is basically, which template engine is being used based on the errors, which based on traceback errors that may possibly arise. And and the other method would be is to try every single payload in a payload list for SSTI. You can easily find them online. There are many payload lists for relevant to different template engines. So you could iterate over them and figure out which one of them returns an error or a successful message. And that is how you would, manually identify what template engine is being used. Typically, nobody would, try to figure out what engine is being used manually. In fact, there is a very useful tool that I'll be demonstrating the use of, and this tool basically takes care of all of this on its own. And yeah, this is basically what would would be going during a successful attack. And okay, I'll be showing you guys a bit of Flask code that is vulnerable to SSTI, along with a bunch of other attacks. And I'll tell you guys exactly what parameter is vulnerable to SSTI, what the template is, and how it is being rendered. So this bit of so basically this is an app.py file, and then you can run it by typing in python.3app.file. And this is the backend code that is being, run when you host this application on a server. So you have this root, which is the index root, and then it takes in name, which is a parameter that is part of the GET request. That name is essentially the name of the parameter, and this is where the vulnerability lies. So it renders template string. Basically, this is the string that is passed as an argument onto the template engine, and then hello, and then followed by name. So whatever you put in here gets rendered. So if you plug in a payload, a valid SSTI payload, then that would lead to a successful SSTI attack. So let's try running this app, and I'm running it on localhost, so I'll be able to access it through the loopback interface 127, right? And this is what the app looks like, and I can enter anything that I want, and it would simply append it to the string and then render it. So yeah, this is what is going on basically. Now for our let's try out our POC payload, and there we go. We have successfully, confirmed the presence of a template injection vulnerability because the interpreter is parsing through this HTML page, and this arithmetic operation is being evaluated, and that confirms the presence of an SSTI vulnerability. Now I've got a standard payload over here, and I'll run you through what that payload is basically about. So just a second. So this text file contains two separate manual payloads that you could enter in order to lead to a successful SSTI attack. So here we have URL for essentially this is Python code, right? Everything that is inside this is Python. So because the app that is being used is a Flask app, and Flask is essentially Python. So URL for is a Python function, and globals is, an accessor which gives you, all, access to all the global variables and modules that are being imported into the file that URL for is present in. So this gives you access to various modules that are being imported, and one of those modules is OS. And OS modules is used for multiple purposes to manage, system commands and to run and execute system commands. And popen is one of them. Popen is a function that is part of OS module to execute your own, shell command, right? And then whatever output that is obtained is being read and displayed onto standard output, and it is being rendered again on the page. So that is again a Python function that simply displays is being, output is received from the previous functions. So let's try this payload out and see what happens. And also, instead of cat flag.txt, let's try ls and see what happens. And yeah, so this app.py file is present in this directory, and then here are the contents of this directory. Let's see if we can list out this contents from through SSTI, right? We've essentially, through this payload, we've essentially gained shell access, and let's try executing ls command instead of cat and see what gets displayed. So yeah, I'll replace cat flag.txt with ls and then submit it. I've not run I need to run the file again. Sorry. Yeah, I'll try that again. Okay. Okay, this was cat flag. Instead of cat, I'll try ls and then see what happens. So I've been able to display the contents of the directory that app.py was present in. And basically I've gained shell access through SSTI into the server. And since I've not hosted app.py in a separate, and secure environment like a Docker container, I've essentially gained access to my own system, right? I've gained direct access through my own machine. And yeah, obviously I was running the server on application on local host, so it wouldn't really make sense. But then in an actual CTF challenge, right? If wherever this application is being run in, and if you're able to gain shell access through SSTI, then you'll be able to execute your own whatever command that you can want, depending on the read or write permissions of that environment. So typically in a CTF challenge, an application like this and its directory would be present in a Docker container or something. And you would be able to, if suppose you gain shell access, you would essentially be able to execute your own command. And yeah, so we've successfully been able to print out the directory contents of the directory that the file was present in. And then yeah, flag.txt is simply a text file that is present in this directory, and this was in fact part of a CTF challenge that I set during the previous semester, and yeah, this is basically what you needed to do in that challenge: exploit an SSTI vulnerability and display the contents of this flag. And yeah, this was manual injection of payload. Now let's try out the automated tool that I mentioned earlier, right? In this case, I manually entered this payload, and it eventually led to an SSTI attack. Now let's try out something else. So I'll open another window. Uh, okay, SSTI map is an amazing tool that can be used to. Yeah, so this is basically, before that, let's basically go through our slides again. So this is basically the description of the payload that I entered in just a minute back. And yeah, URL for is a Flask function, and you can access OS module through globals. And then you can enter in your own shell command through popen. And yeah, now let's look at SSTI map, right? Uh, so you have SSTI map.py. So SSTI map is essentially a tool that brute forces through every payload list and tries out every single payload for possibly all template engines that is known to it, and it tries out different combinations of special characters and tries to figure out which template engine is being used. And once that is done, it essentially tries out multiple payloads that could possibly lead to a vulnerability and essentially confirms the presence of an SSTI vulnerability. And then if you specify that you need shell access, then it would give you that if that is possible in an application that is vulnerable. So let's try that out, right? SSTI map dot py, and then we need to specify the URL. So uh, yeah, just a sec. This is the URL that we need, and so while using SSTI map, we specify the URL, and then we need to have a specific parameter that is vulnerable to SSTI, right? It is that parameter which essentially leads to SSTI. So in this case, our parameter was name. If you observe the Flask code, you have name, and this is the vulnerable parameter. So now let's specify that this is the parameter that we need to test, and then uh, name equals, and yeah, these slashes are just escape sequences, so don't worry about that too much. So name equals test, and then we need shell access. So let's specify this flag hyphen s. So let's see what happens. So yeah, we have invoked SSTI map, and then it's basically trying out every single template engine syntax that is known to it. So it's Slim, Tornado, EJS, Cheetah, Twig are all template engines for different applications. And it has found out that the template engine that is being used is Jinja too. And this is correct because ours was a Flask app, right? And it has confirmed that SSTI map is identified. And yeah, it has confirmed injection with this particular character. And since we specified that we needed shell access through this flag hyphen s, we've gained shell access. Now let's type out ls, and there we go. We've been able to print out the directory contents map on our own using this automated tool, and then yeah, there we go. We've displayed the contents of flag.txt, and that's basic.
When you tried to use this one, you had to specify the vulnerable parameter, right?
Yeah,
In this case, name.
yeah.
But like for the general things, you wouldn't have access to the code to decide which particular thing was a vulnerable
Well,
term, right? So how
well,
do you
like
approach
if
it
you
then?
observe the URL when we submit a request, right? When we submit a string into this, right? We can see that name equals this is being sent along with the URL as a get request parameter. So
Okay,
does
okay,
that
yeah.
so that essentially gives you a clue as to what the parameter is, right? Is that
Yes,
clear
yes,
now?
thank
Yeah,
you.
yeah. So yeah, we've exploited an SSTI vulnerability, and that was all about SSTI. And yeah, before we move on, preventing SSTI vulnerabilities can be prevented in multiple ways, and some of them are not allowing users to modify and submit new templates. So this is sometimes unavoidable depending on the use case of the template. So if unless absolutely necessary, then it would make sense to not allow users to simply manipulate parameters and submit. Or you could just use templates in the legitimate and safe use case that I described earlier by simply, passing in variables that are already present as data into it instead of allowing user control parameters to be placed into a template. Uh, yeah, and other than that, we can use logic-less template engines like Mustache, in which so typically I am assuming that in Mustache the interpreter essentially passes through the template, and it can figure out essentially when certain invalid characters are present, and that leads to an exception in Mustache. So I think that's what goes on in case of a logicless template engine. So this would prevent an occurrence of an SSDA vulnerability. And of course, input validation and sanitization. So you can encode special characters that are part of the template syntax and filter them out and ensure that the input that is entered by the user does not contain any blacklisted characters like For example, in our previous case, we had underscores and dots and parentheses in our payload, right? So if an application implements any kind of sanitization on the input, then it would be a right step. It would be a step in the right direction towards preventing SSTI. And then of course sandboxing. So uh, in when you're running an application which involves template rendering, you could implement template rendering in a separate environment like a Docker container in order to isolate it from the rest of the application, so that in case somebody does gain shell access through it, right, they would not be able to do much because it would be an isolated container that is separated from the rest of the application. So those are some of the methods to prevent SSTI. And yeah, just a second. Yeah, so the next topic that we'll be looking at is remote code execution, or RCE. And like I said, template injection has many effects, and one of the most severe impacts of them is nothing but remote code execution, or being able to execute code, remotely on a target server. And yeah, it refers to any kind of vulnerability that allows an attacker to execute arbitrary commands on a target system or server. So there is a clear distinction between injection and remote code execution. Remote code execution is simply an effect that is observed due to a number of vulnerabilities, and SSTI is just one of them, right? It remote RCE can be described more as an effect rather than an actual vulnerability. You exploit a vulnerability to gain certain actions, and RCE is one of them. So hopefully that clears up the distinction between RCE and template injection. And yeah, template injection of course involves templates, so that's another thing. And yes, any kind of application involves a backend bit of code, right? So PHP applications that use PHP have PHP code that is part of the backend, files that are being run. And RCE typically involves getting your own code that is part of this language to execute somehow, and through a remote, you know, by accessing it from a remote location. That is basically what RCE means. So if you have an application that is using PHP, and then let's say it uses a function like eval, which essentially evaluates whatever string that is present as an argument in it, right? So echo essentially prints out whatever comes after that in PHP, right? You use echo to display whatever comes after that, and that is basically a statement that is present in PHP. So whatever is part of eval, which is a function in PHP, gets interpreted and executed as long as it is valid PHP code. And similar to the previous cases, we have taken the parameter called user from the get request and then appends it onto this string. So like I said, an attacker could simply modify this parameter and then plug it into this, bit of PHP code and get it to run right remotely and on the server. And that is how remote code execution works. And yes, this semicolon is nothing but a character that is used to mark the end of a PHP command. So echo and then whatever comes after this, and then semicolon, which is used to mark the end of the statement. And of course, eval also has semicolon at the end. So that is a character that is used in PHP, right? And yes, when there is a bit of PHP code like this that is part of an application, developers assume that users will only provide valid username as the parameter. So they could just provide user equals admin, and then what would happen is echo admin, and then semicolon would get put into eval, and then eval would PHP would the interpreter of PHP would simply parse through the string and then execute it. Since it confirms that it is valid PHP code, it would just execute echo admin, and then admin would just get displayed. And that is the legitimate use case of this bit of code right here. Now suppose an attacker would like to modify this bit of code in an unsafe way. Now they could try entering in something like user equals admin semicolon and then PHP info. So instead of simply admin, they would enter admin followed by a semicolon, which marks the end of this whatever comes before that, and then followed by another bit of arbitrary code that is decided by the attacker. So now, in this case, we have PHP info, which is nothing but a function which outputs sensitive server information like the version of PHP loaded modules and other details. So, I mean, this is nothing but a function that is arbitrary. Right? It can be anything. You can have echo admin followed by any PHP state function over here, right? So we have echo admin followed by a semicolon, and then we have PHP info, and then like we saw, the PHP statement has a semicolon at the end, so that gets sorry, this semicolon at the end, so that also gets appended onto whatever comes before that. So essentially, the bit of PHP code resolves to echo admin and then PHP info, right? So, yeah, this is how an RCE vulnerability could be exploited. They would essentially just enter their own bit of code into a user input such that it gets executed on the server remotely. And RCE is also possible through a file upload vulnerability. So, I'm assuming file upload vulnerabilities were covered in the previous session, right? Were file upload vulnerabilities covered in one of the previous? Yeah, okay. So yeah, you could upload your own, file that contains malicious code into a server and then get it somehow cause it to get executed, and then that would essentially, grant you possibly grant you privileged access or something, depending on what the code is and what security measures are in place. So in this case, a PHP application might allow users to upload images to a directory, and then if the application doesn't verify or rename the files and grants execution rights on the directory, then that bit of code that is part of the file that is getting uploaded could get executed, and then whatever actions that the attacker is desiring could be achieved, and that is how RCE works. And yes, web shell is basically a script that gives you an interface to, gain remote access to a server's OS. And it would look like this. It would be, in case it's a PHP application, it looks nothing but PHP and then this bit of PHP code right here. So system is a PHP function that is used to run and execute system commands, OS commands, right? And then and then yeah, if command is a parameter that is part of the get request, an attacker could simply enter in their own bit of and their own command arbitrary command into this parameter, and then that would be passed on to system function as an argument, and that would get executed. So yes, that's how a web shell would work. Like so, yeah, the file upload uh, case that we just looked at, you could upload a web shell as a file onto a server instead of a legitimate image or something, right? And then cause that bit of PHP code to get executed. So that's how you could achieve RCE through a file upload vulnerability. And I'm assuming that was one of the labs that were present in file upload, right? So so file upload achieving RCE through a file upload vulnerability is one of the basic labs that are present in Portswigger under the heading file upload. So you could, if you haven't already, you can maybe try that out because it's a very simple lab. You just have to upload, a web shell which contains a PHP code. I think the requirement is to read off the contents of a particular file and then submit it to a location. So. And yeah, we won't be having a demo for RC because the file upload example that we looked at has already, assuming, been demonstrated. And yes, these are some of the ways to prevent RC. So yeah, some of the most important ones are ensuring proper validation of user input and blacklisting certain characters such as this is not supposed to be semicolon, so prevent users from entering in certain characters like these which may lead to RCE, right? So in the example that we looked at, the semicolon was what led to a remote code execution attack. So in case the application filters out certain and encodes these characters, then such an attack would not be possible. And adopt secure coding practices and avoid using unsafe functions like eval, exec, and eval and exec basically, eval is basically like we said, like we saw, eval passes through the entered string and renders it as PHP code and then executes it. And then exec is a Python function which is used to execute OS commands. So avoid using functions like these which do not perform proper validation on arguments that are passed on to them. And then, in order to prevent file upload vulnerabilities that may lead to RC, uh, the application should, allow only specific file types and rename files with randomly generated names so that you cannot manipulate the server to execute your uploaded file instead. And any file that you uploaded gets, renamed, right? In case that happens, then a file upload vulnerability would not be possible, like because the application does not know where exact, and the attackers also would not be able to figure out what the, randomly generated name for the uploaded file is, and would not be able to successfully carry out an RC attack through file upload. And yes, storing uploaded files separately outside the server's root directory so that it does not have any privileges and it does not have any execute privileges, right? And also they could certain files could also be stored on a separate dedicated server or on the cloud in order to prevent file upload vulnerabilities. And then some of the other methods are to implement something that's called a web application firewall in order to protect against RC attacks that are automated, right? And if that's the case, then there would be throttling methods that are implemented, and firewalls do not generally allow, unauthorized traffic to gain access and privilege to a server's, architecture. And then adopt the principle of least privilege. So in case certain commands are being executed and in case they're unavoidable, then make sure that they are being executed with absolutely the bare minimum required privilege so that they do not have unauthorized access to other contents, other data, sensitive data that is present in the server. So make sure that they do not have high privilege and root access and stuff like sudo access and stuff like that. And the next topic for today's session is OS command injection. And OS command injection is very similar to RCE with the sole difference that in case of RCE, you inject code that is in the same language as that is being run as part of the backend of the application. So in case of a PHP application, you would inject PHP code, right? And in case of a Flask application, you would inject Python code. But in case of OS command injection, the payload that you would send it to the server, right, is essentially an OS, an operating system command or a shell command in case it uses a Unix-like system and involves a shell. So in case of OS command injection, instead of code, you're essentially entering in commands as part of the payload. So how would an OS command injection vulnerability be possible? Suppose an application takes in user supplied data and then passes into what's called a system shell. So uh, let's say the application uses a function like system, for example, in case it's a Python application. And I'm sure, I think system function is also there in PHP. So in case an application uses a function like system or exec in order to execute, arbitrary shell commands, right? Then and in case it takes in user input and passes that input as one of the arguments onto this function, then that would lead to what is called OS command injection. So yeah, user gets control over the parameters, and in case the user enters in a valid shell command instead of a legitimate, input field, and once this input is being passed on to system or exec, then that would lead to OS command injection. And of course, there should be no validation or sanitization. So that's what would lead to OS command injection. Suppose an application, suppose there exists a shopping application that uses a shell command to query the availability of a particular item. So this would be the URL for the route, and it takes in these parameters, product ID and store ID. And suppose the shell command that is being executed as part of the backend is stock report.pl. I mean, this is not an actual shell command, of course, but then it somehow has this command in order to query for the availability of a particular item from a separate location and through this route stock status. And instead of a valid product ID like 381, like an integer, say an attacker input enters in the following input as product ID. So let's say an attacker enters in an ampersand followed by a shell command, in this case ls, followed by another ampersand, and then 29. So product ID equals ampersand space ls space ampersand and store ID equals anything 29. So then the command would become stock report.pl ampersand ls space ampersand space 29. Now, what is the significance of ampersand here? Here, ampersand is basically a a shell meta character, which is a special character that allows you to, execute multiple shell commands at once. And I'm assuming ampersand leads to execution of all commands that you've entered simultaneously. So here, the command becomes stockreport.pl ampersand, and this would not be a valid command because you're not providing arguments into this command, right? So that would lead to an error. And then you have this command, ls, which is a successful command, which is a valid command, and that leads to successful display of the contents, directory contents of whatever file, whatever directory the application file is in. And if a read or write permissions are allowed, then you can even enter in your own arbitrary shell command and get get it to perform any action that is decided by you in this case, right? And then this is simply to this is not even needed in fact. So this is what the command becomes, stockreport.pl ampersand ls ampersand 29. So here the command that is being injected is ls, and that is possible through the usage of this special character, which allows you to separate commands. And yes, there are many different special characters that you would use depending on the functionality that you would like to achieve. So in Unix-based systems like Linux shells, you have semicolon, which is the command separator that executes commands sequentially, regardless of whether the previous command returns an error or not. So, yeah, so semicolon, right? Any command that is followed by a semicolon. So let's say you type in on your shell, let's say you type in ls semicolon and then cat the contents of any file, then it would first list out all the directory contents, and then it would, once that is done, it would execute okay, no, sorry, sequentially. So it, regardless of whether the previous command was executed successfully or not, it executes the following command. So ls, and then since ls is a valid command, it leads to successful execution of ls, and then it leads to successful execution of the following command, which in my case is cat, and then so ls semicolon cat would lead to ls, and then let's in fact try that out on our. So ls lists out all the contents. So ls semicolon cat, okay, cd cats, right? So it first lists out all the contents and then it cds into a cats. So now let's try out something else. S is not a valid command, right? So S and then semicolon cd a cats. Uh, S semicolon cd a cats. So, like I said, semicolon leads to sequential execution, and this is this is possible because it executes commands regardless whether the previous command led to successful execution or not. So, the command that we tried entering S did not lead to successful execution, but regardless of that, the next command cd acats got executed, and now we are in now we are in this directory, right? C acats. So that's what semicolon is, and then ampersand. Ampersand essentially, like we saw previously, it is is a shell command separator character which runs a command in the background. So in this case, it runs stockreport.pl in the background, and whether or not stockreport.pl is successful or not, it leads to, it creates another prompt, and then you're allowed to enter your own command that is followed by ampersand. So once you do this, stockreport.pl is a new process is created for stockreport.pl, and then while that is being run in the background, you gain a prompt again, and then you're allowed to enter your own for additional commands. So here ls is being executed. And then double ampersand. So yeah, double ampersand is a command separator which runs commands sequentially only if the previous one was successful. So in this case, you are using double ampersand would not work because you're not providing an argument to this command, right? So stock_report.pl has no argument, so this would not lead to successful execution. And then if you gave double ampersand followed by another command, the next command would not get executed because this command did not lead to successful execution. And then piping, you would require piping in case you would want to take the output of a command and then use it as input for a next command. Suppose you want to search for something ls and then you want to grep within it in order to search for a text that in order to search for a text that matches a regular expression that is part of the output that is returned by the first command, right? Then you would require piping. So in case you would in case you wanted to search for something within this, then you would require a pipe character, which is this vertical character, in order to search for something. And yeah, there are many use cases of pipe which I'll not be going on. I won't be going on in this session. And then double vertical bar. So in this case, double vertical bar leads to execution of the following command only if the previous command fails. So in this case, double vertical bar would be allowed. So this command fails, so then ls would be successfully executed because that's how double vertical bar is. And then redirection. In case you would like to redirect the outputs of a command to a file, then you would use this character in order to redirect. And then, yeah, I would like to give you guys a quick and simple demo for OS command injection. So for that, I'll send you guys the link to the lab uh, on the chat as well as on WhatsApp. So you guys are free to try the lab out yourselves. I'll also be sending the link on WhatsApp for you guys to try out. And it's a very simple lab. There's nothing really involved. You just have to, exploit a command injection vulnerability through a vulnerable parameter. And I think the command that you're required to execute is who am I in order to display the current user's name, right? Uh, yeah, just I've sent the link to the lab on WhatsApp in the DC group, so you guys are free to check it out. It's taking a lot of time to load for some reason. Okay. I'll be starting the lab right now. Yeah, so it's a very simple lab. There's nothing really involved. You just have to modify one of the parameters and enter in your own command. We're already kind of running out of time, but anyway, let's see what. Shouldn't be taking this long to load. I've not configured my Firefox to set up the Burp Suite proxy, so I'll have to use the dedicated browser, and that could possibly be why it's taking this long. And I don't know what's going on. Intercept is also off, and am I logged in? I think I'm logged in also. Yeah, I am logged in. Okay, I'm assuming most of you would have solved the lab by now. It's a very basic lab, right? So, okay, and we're already past 9:30, and if we'll see if it's opening. Okay, yeah, looks like it. Okay, yeah, it's very slowly opening. So let's get started. So let's open one of the products, and okay, it's taking way too long for the demo. And have most of you solved this lab by now? I don't know. It's not supposed to take this long, but so yeah, all you need to do is modify one of the parameters to, append your own command at the end of it through a special character, like I said, and it's still loading. Okay, anyway, yeah, so we'll see if the demo is possible and if it's finished loading. But anyways, in the meantime, let's look at some of the few ways to prevent OS command injection. And they are avoiding calling OS commands from application layer code. Basically, avoid using certain functions like system and exec on, as part of code that is as part of the application, so that they don't essentially lead to OS command injection vulnerabilities, and attackers are not able to inject their own arbitrary commands into these functions and lead to their execution. And if possible, use certain functions like OS dot instead if you want to list the contents of a directory, for example, then I think Python OS module provides you with this command with a separate function that is part of OS library like OS dot list dir or something. So instead of using system and then passing list ls as one of the arguments into it, an application could implement something like have a function like os dot list dir and then simply execute that function separately on its own without any arguments. So that in case you would like to list the contents of a directory, then that would be possible without usage of this unsafe function called system, right? And then of course implement strong input validation and verify that input does not contain any blacklisted characters like semicolons, so that which may lead to OS command injection attacks. And then of course adopt the principle of least privilege so that users executing these commands do not gain unauthorized access to sensitive information as such. And yeah, that's basically all for today's session except for the okay. So yeah, we've been able to load the page. Now let's see if our vulnerability is possible. So let's turn intercept on and then let's check for the stock of this particular item. So yeah, we've obtained this request, right? And we've seen that the parameters that are passed, part of it are product ID and store ID, right? Now, all we need to do is pipe basically what is being returned by these commands onto who am I, so that we obtain the current user's name and everything. So and then let's forward it to the lab and let's turn intercept off. So we've yeah, we've been able to still loading. Okay, okay, it's already 9:40 now. Yeah, so anyway, that's basically what you already all needed to do for that lab, and yeah, that's basically it for our session. Now, hopefully, hope nobody has any doubts from any of these three topics from today's session.